Hey everyone, welcome to the SCM Analytics YouTube channel, your go-to place for all SCM related analytical use cases. This is Vicky here, your host for this video, and today we will be learning about the Excel solver sensitivity analysis report using the transportation problem which we solved in the last video. Let's get started. In the previous video, we used the Excel solver to determine the number of pallets that needed to be shipped in the different shipping route options connecting the supply and demand nodes. Here in this problem, the objective was to minimize the total shipping cost to meet the customer demands from its plans. The next obvious question that the management is generally curious about is to understand until what conditions do these optimal solutions are still valid. These sort of questions help in understanding when the cost estimates or the client demand changes, will the solutions we solve for still be the best one to go for? Often, the demand and cost components, which are the constraints and objective coefficients here in this LP model, vary a lot for a business in the real world. In practice, we cannot choose a route simply because we have a very high demand for a customer or a low shipping cost route. OR specialists are often tasked with simulating and finding a desirable solution range that can handle this sort of business variability and help the management take an informed decision. Sensitivity analysis gives you an insight in how the optimal solution changes when you change the coefficient of the model. It also gives you a flavor of until what extent can these changes be applied to maintain the optimal solution solved for. After the Excel solver finds the solution, you have the option to create a sensitivity report, which looks like the image here in this slide. We have primarily two terms to understand. Number one is the reduced cost. Reduced cost tells us how much the objective coefficients, here in this case are the cost estimates, can be increased or decreased before the optimal solution changes. Similarly, the second important term is the shadow prices. Shadow price tells us how much the objective will change with the increase or decrease of the constraint limits, which are the supply and demand constraints. Now, let's look into an Excel spreadsheet model to better understand these concepts. So in this transportation problem, we had been given the following inputs. The first input is the shipping costs for the different routes and the supply and demand constraints. The total supply of the network is 100 and the total demand across the four customers is also 100. We construct this LP problem with balanced constraints where we give a constraint that is the total shipment that we can do from plant A is equal to the total supply of 30, and similarly the total demand for customer C1 that would come from the different plants is 22. The total cost is again nothing but the sum product of the decision variables and the cost metrics. Let's now solve this problem and understand the, the concept of sensitivity report. Now here the objective is the total cost which we want to minimize by changing the shipment value, meeting the supply and demand constraint, and we use the solving method simplex LP. On solving this solution, we get the following output. Let's now take an example of plant A. So the optimal solution is to ship 2 pallets from plant A to C1 and 28 pallets from plant A to C4. By doing so, you meet the 30 supply constraint for plant A and the different demand requirements of the different clients. For C4, the entire shipment comes from plant A. And one can notice that the higher shipment happens on the routes where the costs are lower, which makes a lot of obvious sense. Now let's try to understand the changes in the cost metrics and how it would affect the decision variables or the different routes that we select and the total cost. So do so, click on the sensitivity report option in the solver result and click on OK. Now after doing this, you would see a new tab with a new report in it. Let's now first try to understand the reduced cost concept, and to do so, I would like you to focus on the decision variable plant A C2. Here for this particular decision variable, the objective coefficient is 7. So that basically means that to ship one pallet in this route, it would take $700. Here in column G and H, you are given with two limits. Any increase in this objective coefficient to infinity would not make any difference to the solution that we find. And similarly, the max permissible decrease in the objective coefficient is 6. Any cost that goes below $600 would change the optimal solution. That's how you would read and interpret this particular reduced cost. Now let's look into the transportation problem, simulate what we just observed from the sensitivity report and get a better understanding of it. Now I go to the C2 cost variable and I change it to 6, which is within the permissible decrease range. Now from 7 to 6, I decreased by 1 and I'm very sure that these optimal solutions that we found out before will not change. I go on the solver, I click for solve, and like you can see, the results did not change. But now if I make it 5, this would lead to a change in the optimal decision variables that we have solved before. Let's solve again. And now you see that the shipment units have changed. It now no longer makes sense to meet or send two pallets from plant A to C1. Rather, the two pallets that we were sending before goes to C2 and the entire C1 demand is met by plant C. By doing so, the total cost also reduced from 289 to 287. Now that we have understood the concept of reduced cost, let's look into the concept of shadow prices. For shadow prices, we look into the second case of the transportation problem. This case is a situation where you have more supply than the demand in the network. Here, across the three plants, we now have a total supply of 110 and the demand still remains at 100. In this case, the total optimal cost at this situation with these cost metrics stands at 289. Now, when we change this demand variable, demand and supply constraints, we want to understand how the objective coefficient will change. And often the business would want to understand in which plant should I increase or invest more in capacity in order to reduce the cost and further meet my client's demands. Now, let's click on solver, solve for this problem and generate the sensitivity report. In this case, we have been given the following information. I will now like to spend some time to interpret these values. Now, if I had increased the supply in plant B from 40 to let's say 42, I can expect the total cost of the network to decrease by minus 4 into 2, which is minus 8. So a unit increase in the supply of plant B would decrease the total cost by minus 4. This is the interpretation of shadow price and how it's linked with the supply constraint. Similarly, for plant C, the total cost or the total shipping route cost would decrease by 2 with every increase in the supply of plant C as well. But the allowable limit is just 2 units, and similarly the decrease would be 10 and 8, before which these solution will not change. When I mean that the optimal solution would not change or the routes decision variables will not change between these ranges of changes. Now let's examine by changing and seeing how the cost function changes. So let's go ahead and increase the supply of plant B by 2 units. So from 40 to 40, I make it 42 and I click on the solver. What I can expect is that the total cost will become 281. Like expected, the results leaded to a decrease of minus 4 into 2, which is 281. So if the management has to increase the capacity at some plant and reduce the cost, it would be at plant B. Now let's try to understand from a demand perspective. I resolved the problem to bring back to the original status of this sensitivity report. Now, with every increase in demand for customer C1, I can expect the cost to increase by 8. And with every decrease in the demand of customer C1, I can expect the cost to decrease by minus 8. So that's the interpretation in this case. And if there's a customer which is super costly for the network, it's C1, because with every increase in demand of C1, you would incur a cost of 8. So let's go ahead and change these demand constraints and see how the network changes. Now when I decrease the demand to 21, I can expect the cost to become 281, and with increase in the demand to 23, I can expect the total cost to go to 297. Let's experiment on that. So on solving this problem, like I expected, it became 281. Now if I increase this limit to 23, I can expect from 289 plus 8, which becomes 297. I hope you got a flavor of what reduced cost and sensitivity reports are and how to interpret them. So that's all for today, folks. The contents present in this video are available in the description below. Thank you for watching, and I hope this video was useful. Please subscribe to the channel and click on the bell icon for updates on future videos. Until then, take care, bye, and happy learning.